Welcome to the fifth session of our second module. So in this session we will do some numerical problems based on isentropic flow, some 2-3 problems, and you will get some nice idea about how to solve a problem based on isentropic flow, and I will be giving some assignment questions or tutorial. So if you follow these 3 problems, I'm sure you will be able to crack any type of problem that come across in this topic. Okay, so first a basic problem. So here at a section in an isentropic flow passage, air is having a temperature and pressure of 27 degrees Celsius and 1 bar respectively, and is flowing with a velocity of 300 meter per second. What will be the pressure and temperature of the fluid in the reservoir from where the flow has started? The students note this word reservoir. So reservoir pressure and reservoir temperature. So what is that? That is nothing but stagnation pressure and stagnation temperature only. So P0 and T0 are unknown. So they have those things have to be found out. So P0 and T0 have to be found out. So students, what are the given data? So given here at a particular section temperature is 27 degrees Celsius, means how much Kelvin? So almost 300 Kelvin, right? 300 Kelvin. And pressure P equal to 1 bar or 1 into 10 raised to 5 Pascal. Okay, so pressure is 1 bar and is flowing with a velocity V 300 meter per second. So we have to find P0 and T0. Okay, so students, velocity is 300 meters. Another point is that fluid is here air. It is given that fluid is air. So if it is given as air, means you already got the value of gamma as 1.4, Mach as how much? Sorry, not Mach, R as 287 joule per kilogram Kelvin, right? So already you got these values. Okay, so if the fluid is there, it won't be given in the question that any value for gamma or R. It is already understood, and in the question if it is some other fluid and the data are not given, means you can directly check in gas tables. It may be available in the gas tables, like properties of different fluids. You can search in the gas table. Okay, so don't worry about that. So these are the things given data: temperature, pressure, velocity is given at a particular section, and gamma and R are given. Okay, we have to find T0 and P0. So students, we have learned the equation for T0 equal to T into 1 plus gamma minus 1 by 2 max square. So this is the equation for T0. So since we have the value of gamma and we don't have the value of Mach, so we have to find the Mach. So Mach can be written as Mach equal to V by A at that particular section. So V is 300 and A is not given, but A can be written as gamma RT, right? So 300, so Mach is 300 by root 1.4 into 287 into 300, so it will be around 0.864. Okay, students, now T0 is T into 1 plus 1.4 minus 1 by 2 into 0.864 whole square. Okay, so this is so here T is nothing but, how much is T? Here T is 300. So you will get the value of this equation, solving this equation you will get the value around T0 as some 345.2 Kelvin. Okay students, this is how, and now this is how you find the value of T0. And now I will show, so you don't follow this method, don't follow this method. Okay, you can directly get the value of T0 using gas tables. So that is the important point. You don't need to apply this particular equation here. You don't need to apply this equation. Without applying this equation, you can directly get the value of T0 using gas tables. So that is the easy method to get values, because sometimes you can easily remember this equation for T0 and P0 and all, but the case where there F by F star, A by A star, and P star by P, T star by T, all these things you won't be able to easily memorize. There are a lot of equations. So since there are a lot of equations, you have to go through a different approach. So that approach is using gas table. Okay, I will show you how to use gas tables. Okay, so students, this is the table from gas table. The gas table for I have shown you the gas table in the previous session. So here our gamma equal to 1.4, and this is a table for isentropic flow. So you have to fix the flow. Okay, so our flow is isentropic type, so use the isentropic flow chart for perfect gas, gamma equal to 1.4. And our Mach, you have to obtain Mach anyways, because this is a function of Mach and gamma only. So you have to find the value of gamma and Mach. So gamma here, so gamma is 1.4, Mach will be 0.864. So students, you have to corresponding to the value of 0.864 of Mach number. So here, so this is 0.86. You will get T by T0 as, so since our 864, I am just approximated. You have to do interpolation on all if you have to get the correct value. So I think you know the method to interpolate. I have taught you in your HMT class and all. If you do interpolation, you will get the value of T by T0 corresponding to T by T0. You will get 0.87. So T by T0 is 0.87. So T0 will be T by 0.87. So T is T for the particular section where Mach number is T corresponding to Mach equal to 0.864 is by 0.87. So this is will be 3 T0 will be 300 by what 0.867, sorry, 0.871. So that value will be around 345. So directly we obtain the value of T0. So this is how you use gas table. Similarly, P0, you learn the equation P0 equal to P into 1 plus gamma minus 1 by 2 max square into gamma by gamma minus 1. This equation you know, but you don't need to apply this equation from gas tables. P by P0 corresponding to Mach equal to 0.86, sorry, 865 is around, we get from this P by P0. Here you can see some 0.617, right? 0.617. Okay, so P will be what will be the value of P? P equal to, sorry, P0 equal to P by 0.617, and that will be equal to P is 1 bar. 1 bar by 0.617 is around 1.63 bar. So this is how you find the value of P0 and T0 using gas tables. So directly you will get the ratio T by T0 and P by P0 corresponding to each Mach number, corresponding to the Mach number of the particular section and gamma of the flowing fluid. Okay, this is how we solve this problem. We will move to next problem. So the second problem, air flows isentropically. So here our working fluid is again air. It flows isentropically through a duct. So Gamma equal to 1.4, that is obtained air. Flow is isentropic through that. At a particular section, the cross-sectional area is 400 mm square. Okay. And Mach number equal to 0.4. At another section, area is 300 mm square. What is the Mach number of the second section? What would be the area of the section where m equal to 1? These are the questions. Okay. So we have a duct. At one particular section, area is 400 mm square. Okay. Another section, area equal to 300 mm square. Okay. So here Mach equal to 0.4. Here Mach is unknown. So what the Mach at section where area is 300 mm square is to be found out. So our question is Mach number at area equal to 300 mm square. So that should be found out. Only thing that is given is gamma equal to 1.4. The Mach number at the section where area is 400 mm square. So Mach number at area 400 mm square equal to 0.4. Only these two things are given. So how to solve this problem? So students, since this is a problem involved with area, we will use the technique of we will use this particular term A by A star. So students, in this gas table you can see a particular term called A by A star, and we have already derived the equation for A by A star, but you don't need to apply those equations and all. You directly obtain the value for A by A star from uh, gas tables, and before that we have to optimize the problem. So students, this area A1, call this area, okay, call this area is A1 and this area is A2. Section 1 as section 1 where area is 400 mm square is A1 and the other section is A2. So students, A1 by A2 sorry, A2 by A1 can be written as A2 by A star by A1 by A star. So this is the crux of the problem. This is the main crux of the problem. If you apply this particular equation, A2 by A1 can be written as A2 by A star by A1 by A star, then you can easily solve the problem. So understanding this particular concept or this particular idea, then the problem is over. Okay. So A2 by A1 can be written as A2 by A star by A1 by A star. Okay. Understood? Now, so what is A2 by A star? So here A2 by A1 is nothing but 300 by 400. So that is understood. That is equal to 3 by 4. Okay. So 3 by 4 is equal to A2 by A star by A1 by A star. So what is A2 by A star? Means the ratio of area of the section where the Mach number is unknown, and A1 by A star is the ratio of area of cross section where Mach number is 0.4 to the critical section. So here Mach equal to 0.4. Here Mach is unknown Mach. So this is M2, this is M1. Okay. So this is Mach M2 and this is M1. So students, now use the gas table. So area 1 by A star, or that is Mach equal to 0.4 is obtained directly from table. So bring the table. So bring the table here. So here A by A star is at Mac equal to 0.4. So Mac equal to 0.4. So here there is no, you have to get the next page. Wait. So students, look at here. At Mac equal to 0.4, A by A star should be found. That value is around 1.590. Okay. So 1.590. So 3 by 4 equal to 1.590 by A by A1. Sorry, what is A1 by A star? So this is wait. A2 by A star by 1.590. This is Mach number 2. So this is unknown. So this value can be calculated with this equation. So A2 by A star at Mach 2 is 3 by 4 into 1.590, and that value will be around 1.1925. So if you calculate this value, you will get 1.192. So you got a value for A2 by A star. Okay, A2 by A star value is obtained. Now you have to then, corresponding to this A2 by A star, you can find the value of corresponding Mach number from the gas table. How? So you just use this value and now go to your A by A star or the Mach number on the table. So corresponding to 1.1925. So you check here 1.1925. So 1.1925. So here you check. Okay, somewhere here. So this is 1.2, around 1. Okay, 1.188 is here. So 1.1925 is between 1.1, 1.2 and 1.18, right? So it is a value. So the Mach number corresponding to that particular A by A star ratio is around, if you interpolate, you will get around 0.595. Mach as 0.1, M2 as 0.5925. Sorry, 0.595. So that is the value of M2. So you just reverse. You just do the reverse method. So corresponding to A by A star equal to 1.1925, you will get the Mach number from the gas tables as 0.195. So that is the question. You were asked to find the what is the Mach number at the second section. So you got the Mach number. Okay. So the Mach number at the second section is 0.595. Now one more question is there. The last question is, what would be the area at the section where Mach equal to 1? So area at the section where Mach equal to 1 is the value of A star. That is a critical section or throat section. You just find the value of A star. Now we have to find the value of A star. A star equal to question. So students, at A by A star, A1 by A star at Mach equal to 0.4, you got it as 1.59, right? So A1 by A star equal to 1.59. A1 by A star equal to 1.59. Okay, A star equal to 1.59. A1 by 1.59. So A1 is 400 by 1.59. So that value will get as 251.57 mm square. So that will be the area corresponding to Mach equal to 1 or critical section area. Okay, understood? So this is how we solve the problem involving area. So in the previous problem we found the stagnation or reservoir pressure and temperature. Here we found the area at, we understood how to find the area at different sections, or how to find the Mach number at a particular section where area is given. So such problems are solved. Okay, now we will move to one more problem, a little bit tougher problem. Okay. Students, here air enters a variable area duct at a pressure of 350 kilonewton per meter square. Okay. So a temperature of 27 degrees Celsius and a velocity 150 meter per second. The area of cross section at entry is 500 centimeter square and the exit area is 350 centimeter square. The flow is isentropic. Determine mass flow rate through the duct, pressure, temperature, and velocity at exit from the duct, change in inverse motion. So students, we have a duct and air enters. So this is entry, this is exit. This is entry is 1, exit is 2. Air enters at a particular pressure P1, T1, V1. Okay. P1, T1, V1, and area is 500. Area is 500 centimeter square. Or you mark it as A1. P. So this is 1, this is 2. P1, V1, T1, A1 is given. All these four things are given. And T2 at the exit section, what is given? A2 is given, 350 centimeter square. Now we have to find T2 equal to unknown, P2 equal to unknown, and V2 is also equal to unknown. Okay, so only A2 is given, and we have to find m dot mass flow rate through the duct also to be found out, and also third one is change in inverse motion is F1 minus F2 is to be found out. So m dot should be found out, all these three values should be found out, and this value also should be found out. So given P1 equal to 350 into 10 raised to 3 Newton per meter square. Okay, T1 is equal to 27 degrees Celsius means 300 Kelvin. V1 equal to 150 meter per second. A1 equal to, you just make, okay, just make it in a SI unit. Okay, 500 mm square means 5 into 10 raised to minus 2 meter square. So this is SI unit. Now very important, as soon as you are given with the velocity, you try to find out the Mach number at 1. So Mach number at 1 is always V1 by A1. It will be equal to V1 by gamma RT1, since the fluid is air. So gamma equal to 1.4, R equal to 287. Okay, so V1 by root 1.4 into 287 into 300. Okay, so V1 is given as 150. So you will get the value of M1 as 0.432. Mach number at section 1 is 0.432. Now you have the A2 value of A2 is known. So what is the value of A2? A2 is 3.5 into 10 raised to minus 2 meter square. Okay. So students, since we have two areas, you can apply the equation of A1 by A1 by A2 is nothing but A1 by A star at Mach 1 by A2 by A star at Mach 2. So this is 5 by so what is A1? Okay, 500, 5 by 3.5, right? 5 by 3.5 is equal to this particular value, right? or 3.5 by 5 is equal to A2 by A star at Mach 2 by A1 by A star at Mach 1. Okay, so A1 by A star at Mach 1 can be found out using gas table. So use the gas table. Now A1 by A star at Mach 1 is how much? Because Mach 1 is known. Mach 1 is 1 equal to 0.432, right? So 0.432 you will get from gas table. So you just use the gas table. So here 0.432, right? 0.432 corresponding to that it will be around 1.495. Actual value will be 1.495. Okay. So 1.495. This value is obtained from gas tables. So substituting this particular value here, 3.5 by 5 equal to A2 by A star at Mach 2 by 1.495. So you will get A2 by A star at Mach 2 is equal to 1.0465. After calculation, you do the calculation, you will get the value is this. Okay, so from this equation you will get a Mach 2. How? You just search in the gas table for the value of A by A star as 1.0465, and you read the value corresponding Mach number value 1.0465, right? So here you will get 1 point. So search in A by S 1.0465 will be around here. So that corresponding that value will be some 0.78. So Mach number will be 0.78. So you will get Mach 2 as 0.78. So students, now you have got the value of Mach 2. At second section you got Mach 2, the value of Mach 2. If you got the value of Mach 2, then you can find the value of T2, P2, all the value you will get. How to find? The P2 can be written as, so P2 by P0 corresponding to M2 can be obtained from the table, right? So here corresponding to 0.78, P by P0 is 0.669, T by T0 is 0.892. Okay, 0.892. So mark those things. P2 by P0 equal to much 0.669. T2 by T0 at Mach 2 is obtained from the table as 0.8915. So you got these two values, but you don't know P0 and T0. So that's the problem. You are asked to find P2 and T2, but you don't know the value of P0 and T0. So how can you use this equation? Students, the idea to solve this problem is P1 and T1 are known. So P2 by P1 can be written as P2 by P0 by P1 by P0, right? So P2 by P0 is means at M2. This is at M2, and this is at M1. So this is M2, this is M1. So corresponding M2, you got the value as 0.669. And P1 by P0 corresponding to Mach 1 is obtained from the graph, obtained from the table as 0.881. So you will obtain this, M1 is known, no? So you can obtain this P1 by P0 from this graph as 0.881. So this will be, and P1 is also known, right? P1 is known. So P2 is equal to P1 into 0.669 by 0.881. So P1 is 350, some 350 kilonewton per meter square into 0.669 by value of pressure at the second section as 266. Okay, 266 kilonewton per mm square. And now similarly T2 by T1 can be written as T2 by T0 by T1 by T0, right? So this is at M2 and this is at M1. So from the gas table, this value you will get it as, you already got it as 0.89, and the other value you will get it at 0.96. So T1 is 300, so T2 equal to 300 into 0.89 by 0.96. So you will get the value as T1 as T2 as 277 Kelvin. Okay, 277 Kelvin. Now V2 is nothing but A2 into gamma, A2 into Mach 2, right? A2 into Mach 2, right? So Mach 2 is known. So V2 equal to Mach 2 is 0.78 into A2 is root gamma R T2, and T2 is 277, you will get as 260 meter per second. So this is the value of velocity at the section 2. This is 0.78, okay, 0.78 into gamma R T2. So P2, T2 and V2 are obtained. Now we have to find the, so what else we have to find? We have to find, so here mass flow rate, m dot should be found out. So how to find m dot? So equation for m dot is easy equation, rho AV only, right? Rho AV is either rho 1 A1 V1 or rho 2 A2 V2. So I am taking rho 1 A1 V1. So rho 1 is P1 by RT1 into A1 into V1. So P1 by RT1 into A1 into V1. So P1 is known, T1 is known, A1 is known, V1 is known. So take all the things in, while multiplying you have to ensure that every terms are in SI unit. So you will write P1 as 350 into 10 raised to 3 Newton per meter square by 287 R into 300. Area is 5 into 10 raised to minus 2, 5 into 10 raised to minus 2 into V1 is 150. So your value will be 30.5 kilogram per second. So this is m dot. Okay. Finally, we have to find the value of F1 minus F2. Change in impulse function. This is very important. F1 by F2 is unknown. So students, you know the equation for F1 as some P1 V1. P1 into A1 into 1 plus gamma M1 square. So this is equation for M1, F1, F2 can be written as P2 A2 into 1 plus gamma M2 square. So if you substitute the value for P1, A1, M1, P2, A2, M2, and if you find the difference, you will get the value of F1, F2. But I am opting a simpler method. Simpler method is using gas table. So how to solve it using gas table? So F2 minus F1 can be written as F1 into F2 by F1 minus 1. I am taking F1 as common. So F1 by this can be written as F2 by F star at Mach 2 by F1 by F star at Mach 1 minus 1. So the value for these two can be obtained from our gas table. So where is our gas table? So M2, the value of M2 is 0.78, right? So corresponding to 0.78, you will get the value of F by F star here, 1.023. And similarly, corresponding to 0.432, Mach 1 is 0.43. So here it will be 1.311. Students, you can substitute the values like F2 minus F1 can be written as F1 into, in the numerator it will be 1.023 by denominator 1.311 minus 1. Okay, but the value of F1, okay, you have to find out. The value of F1 is 3, F1 is P1 A1 1 plus gamma m square, m1 square into, this value will be 0.7809 minus 1. So P1 A1 is 350 into 10 raised to 3 into 5 into 10 raised to minus 2 into 1 plus 1.4 into 0.432 square into some 0.6809. So you will get the final value as you get the value as I think it will be 483604. Okay, so F1 minus F2 equal to 483604 Newton. So it means impulse function is reducing from 1 to 2. 1 minus 2 equal to 483. Impulse function is reducing towards the second section. So this is how you find F1, F2 using the gas tables. So with this I will conclude this session. Thank you.